What happens when a statistician names a recently discovered dinosaur with one hump that's symmetric about the median? He calls it a normal curvosaurus, and we will continue working with the normal distribution. So in this example, what we're going to do is we're going backwards now. So we're looking at percentiles and figuring out what values will give us a percentiles instead of trying to figure out percentiles from values. So in this example, we have adult male heights are on average 70 inches, 5'10", with a standard deviation of 4 inches. How tall must an adult male be to be in the top 10% for his height? So top 10% means what on the curve? Well, it means you're going to be over here, right? And to the left of you will be 90% of the curve, or zero point 0.9 of the area. Remember, the total area for the normal distribution is 1. So what z-score would result in the top 10%? So what we have to do, we're not going to use the yellow if we're using the table. We're going to use the green because the table goes from left to right. And actually, we're always going to be using this left area, whether you're using the table or the calculator. So let's go ahead and pull up the table. And looking for 0.9, you can see it's right. The closest number to it is this one right here. And I can get the z-score from, here's the beginning of the z-score, 1.2. And then the hundredths places from these column headings, so it's 1.28. Now it's much easier to go ahead and get a z-score from your calculator. And this is how you do it. First of all, you're going to press second in distribution like we were doing before. But instead of normal CDF, you're going to scroll down and hit inverse norm. All right. And then you put the area, in this case 0.9, and enter. And you can see it gives you the z-score, which is the same as what we had earlier. So now that we have a z-score, how can we tell how tall an adult must be? Well, here's the z-score for that value. We know it's 1.28. And we have this equation, which is on the back of your math chart. Z equals x minus mu over sigma. These, again, are population parameters when you have mu and sigma. And we say 1.28, because that's the z-score we're using, is equal to x minus 70. Remember, 70 is our average, and 4 is our standard deviation. Well, I can just put a 1 underneath it and cross multiply. And I'm going to get 5.13, that's from 4 times 1.28, equals x minus 70. When I add 70 to both sides, I get x is 75.13 inches. So an adult male must be at least 75.13 inches to be in the top 10% of their height. Okay, let's look at another example. We have tomato box fillers are designed to get an average fill of 80 ounces with a standard deviation of 4 ounces. 95% of boxes will weigh at least what? So what that means is that I want so I'm only leaving 5% off to the side. And I'm guessing that this is roughly 5%. And maybe it's a little more this way, maybe it's a little more that way. But one thing I do know is that this green area is 0.05 and this yellow area is 0.95. If I use the calculator, which is pretty straightforward, I'm going to do inverse norm of 0.05 because that's this area right here. And I will get negative 1.645. I could have also looked it up on the table. It would have probably given me somewhere between negative 1.64 and negative 1.65. Okay, so now I have the z-score. And I can go backwards. Let's go ahead and write down our formula. And then we put in the z-score. We know our average. We know our standard deviations. And we can solve for the x that goes here. Go ahead and cross multiply. And you get negative 6.58 ounces equals x minus 80. Add 80 to both sides. And you get 73.42 ounces. So at least 95% of the boxes weigh at least 73.42 ounces. Okay, so now let's say they want the boxes to really weigh 76 ounces, but they weigh 73.42, which is here, right? And the difference between our target and our current is 2.58 ounces. We're 2.58 ounces low. So one thing we can actually do is just increase all of the weights so that the new average is going to be 82.58. So that would be your new answer. You would adjust the machine so the new average is 82.58. Okay, now let's say they do a different tact and they say, well, we really don't want to be putting that much extra tomatoes in the boxes because that costs us money. It does cost us money to slow down the production line, but let's go ahead and try that instead and see what it looks like. So we're still going to have a mean of 80, but they want the 95% of the boxes to weigh 76 ounces. So they want 95% of the boxes that this is at 76 ounces. Well, this is a lot like how we started the problem. We still have that 0.05 area here. So we get negative 1.645 for the z-score. Pull up the formula and substitute. Notice now that we do know our x and we do know our mean. The thing we don't know is our sigma, all right? Well, we can go ahead and put a 1 under this, right, and cross multiply, and you're going to get negative 1.645 sigma equals negative 4 ounces. Well, basically, you can just solve for that by dividing by negative 1.645, and you get 2.43 ounces. So if they can make it a little tighter on the spread, instead of having what they had before, which was 4 ounces as their standard deviation, they could make it 2.43 ounces. So whatever they have to do to slow it down to minimize their variability.